All right, let's dive into a question that could genuinely shake up everything we know about physics. For a long time, we've had this pretty solid picture of how the universe works. But what is the biggest, most mysterious force out there, what we call dark energy, isn't what we thought it was? What if it's changing? And look, this isn't just some little tweak to an old theory. We're talking about new results from a massive project that are putting some serious pressure on the very foundations of modern cosmology. It's like we've just found a potential crack in our most complete picture of the universe. And you don't have to take my word for it. The scientists behind this are pretty excited. Michael Lovi, who's the director of the project, called the Dark Energy Spectroscopic Instrument, or DESI for short, he really hit the nail on the head. This new data just doesn't quite fit with our other measurements, unless you allow for the idea that dark energy can change. Then, suddenly, everything clicks into place. So that's the billion-dollar question, isn't it? Is it possible that this invisible energy, this thing that makes up the vast majority of our reality and is driving the whole cosmos apart, is actually evolving over time? The answer could completely rewrite the future of, well, everything. Okay, so before we get into the wild new results, we need to understand what they're up against. Let's talk about the current reigning champion, the theory that has done an amazing job of explaining our universe for decades. This is the model that's now facing a serious challenge. So for years, scientists have had what you could call a standard recipe for the universe. And here's the crazy part. Everything we see, everything we can touch, the stars, the planets, you, me, all of it, that only makes up about 5% of the total cosmic pie. The rest is just a mystery. About 23% is dark matter, which kind of holds galaxies together, and then the biggest slice of all, nearly 73% is dark energy, the stuff that's pushing everything apart. Now, this recipe has a proper scientific name, the Lambda CDM model. And you know what? It's been incredibly successful. It explains the leftover glow from the Big Bang, why galaxies form these huge cosmic spiderwebs, and most importantly, it accounts for the fact that the expansion of the universe is actually speeding up. This whole model really rests on two main pillars. On one side, you've got cold dark matter, or CDM. That's the invisible gravitational glue we were talking about. And then you have lambda. That represents the cosmological constant. And that word right there, constant, that's the key. The entire standard model is built on the idea that the strength of dark energy never, ever changes. But what if it does? What if it's not a constant at all? Well, that's exactly where this new evidence comes in. A truly groundbreaking experiment has been mapping the universe, and it's starting to find some tantalizing hints that this constant might not be so constant after all. And we're not talking about a small study here. The DESI project has created the largest 3D map of the cosmos ever made. I mean, get this, we're talking about mapping the precise locations of nearly 15 million galaxies and quasars, looking back over 11 billion years of cosmic history. The sheer scale of this thing is what makes its findings so compelling. So how in the world did they do it? It's actually really clever. Picture the baby universe as this thick, hot soup. Sound waves were rippling through it, creating these giant spheres of matter. When the universe cooled down, those ripples basically froze in place, leaving a sort of fingerprint, a preferred distance between galaxies. This pattern is called Baryon Acoustic Oscillations, or BAO, and it acts like a cosmic standard ruler. We know how big that ruler was back then, so by measuring how big it appears at different times in cosmic history, DSI can map out the universe's expansion with insane precision. And that's where they found that things don't quite add up. Now, let's be super clear about what this means. In particle physics, the gold standard for claiming a discovery is something called 5 sigma. That means there's only a 1 in 3.5 million chance your result is just a random fluke. DESI's hint of a changing dark energy is currently at about 4.2 sigma, so it's not quite a discovery yet, but it's an incredibly strong sign that something really interesting is going on. So this leads us to the real so what question. If dark energy is actually getting weaker, it's not just some minor correction in a textbook. It fundamentally changes our entire understanding of the ultimate fate of the universe. The leading idea for changing dark energy is a theory called quintessence. It basically proposes that dark energy isn't a constant number, but a dynamic field that can evolve over time. The best analogy is to think of a ball rolling down a hill. As it rolls, its potential energy changes. Quintessence suggests dark energy might be doing something like that. And what the DSI data seems to hint at is that the ball is in fact rolling, and its energy is decreasing.
For years, our standard model, with its constant dark energy, pointed toward a pretty bleak destiny called the Big Freeze. In this version of the future, the universe just keeps expanding faster and faster. Galaxies fly so far apart they disappear from view, all the stars eventually burn out, and the cosmos just becomes this cold, dark, empty nothingness forever. A very lonely end.
There's another possibility. If dark energy were to get stronger instead of weaker, that's called the Big Rip. The repulsive force would get so incredibly powerful it would overcome gravity, and, well, it would tear everything apart. First galaxies, then solar systems, planets, and eventually the very atoms that make us up. A much more violent and spectacular finale. But, and this is the really exciting part, if this new DESI data is pointing in the right direction and dark energy is weakening, then a third option is back on the table, the big crunch. If that outward push from dark energy fades away, gravity could become the dominant force again. The expansion would slow down, stop, and then reverse, sending everything collapsing back in on itself, into a single, incredibly hot, dense point, maybe even kicking off a brand new Big Bang.
So, where do we go from here? Well, this isn't the end of the story. It's actually the incredibly exciting beginning of a whole new chapter. We are right on the verge of either confirming our standard picture of the cosmos or discovering that it's far, far stranger than we ever dared to imagine.
And the hunt for answers is on right now. The evidence is building. DESI is still out there, night after night, collecting more data. Its full 5-year survey, combined with results from other big projects like the Euclid Space Telescope, is going to be absolutely crucial. Over the next few years, this hint could either fade away or it could solidify into a Nobel Prize-winning discovery. And that's really the ultimate takeaway here. This new data forces us to grapple with a really profound idea. We tend to think of the laws of physics as these eternal, unchanging rules. But what if they're not? What if the universe we see around us is just one temporary phase in a much larger and still completely unknown cosmic story? That's what we'll be watching for. Thanks for joining us.